The next lesson is about simplifying algebraic expressions. This is kind of our beginning unit. It goes over 2 days here. We're going to get a little bit more complicated in the second day. To break it down, there are some vocabulary words for you. The first word is a term. A term is each part of an algebraic expression that is separated by an addition or a subtraction sign. If you'll remember expression from the other day, this is just a kind of mini thing. It only has letters for variables, it has numbers, and it also has operations then. So those are terms, pieces of the algebraic expression that get separated by addition or subtraction signs. So if I had 4x plus 3y plus 7, the 4x is a term, the plus 3y is a term, and the plus 7 is a term. So there's 3 different terms there. If they are like terms, this will make sense to you. Like terms are terms that have the same variables to the same power. So we are going to start to see some exponents here. If I had something x squared and something x cubed, they have different powers. Powers is talking about the exponent. So these would not be like terms. However, if I had 4x and 5x, these both have x to the first power, they would be like terms. The final vocab word here is a constant. It's just a term without a variable. So in our words, it's just a number. That's really what a constant means in math class. So the first part asks you to go ahead and figure out, are these terms or like terms? First one, 4x and 4. This has an x, it doesn't, so they are just terms. They would have to have this would have to have an x to be like. 4x and 3x, these are like terms. They both have an x to the first power. The number out front is called the coefficient, and it's telling you how many there are. So there's 4 x's here and 3 x's here. 3 and 5, they're both constants, so they are like terms. 3x squared and x. Notice how the power here is 2. The power here isn't written, so it's assumed to be a 1. They're different, so they're just terms. X and y, they're not even the same letter, so they're just terms. 3y squared and y squared. These are actually like terms. They both have y squared. Real quick note here that we've kind of been assuming and working with, but it says often a variable doesn't have a number in front of it. In this case, there is an understood 1 in front of the variable, and there's also an understood 1 in the exponent. So I always explain to people that b is really saying 1b to the first power. A negative a would represent a negative 1a to the first power. So what we're doing here, our question is, what does it mean to simplify an expression? In our case for today, we're going to be going through and we're going to combine like terms. I call this CLT, combine like terms, CLT, and actually learned from another teacher to call it chicken, lettuce, tomato. So you're going to hear me refer to it that way. For this part right here, I'm going to break it down super easy, so I recommend that you draw a box around the expression, split it up into the terms. Remember, it's the addition or the subtraction signs that break it up. 5m, boom, stop, plus 9m, stop, plus m. For our purposes, we're going to write in that this is a 1m because it's going to make our life easier. This is an m to the first, m to the first, m to the first. So these are actually all like terms. So all we do is add together the numbers out front. 5m plus 9m is 14, plus 1 more is 15. If it helps you to think about these as an object, 5 mangoes plus 9 more mangoes plus 1 more mango, go for it. Next example, box it up, split it into terms. 3a, stop, plus 2, stop, plus 4a. This one's a little different. This has an a and that has an a, so they are like terms. Grab another colored pencil here just to kind of demonstrate to you. Oops, and we almost lost that. Sorry about that. What happens when you're trying to rush, I guess. And then we have a plus 2, which is just a constant. So I'm going to color that in differently just to show that it is a different term. So if I have 3 apples plus 4 apples, that gives me 7 apples. And then I still have a plus 2 that just chills out. Notice that I'm simplifying my expression. I really can't do anything else here. Example 3, go ahead, box it up and split it up. 3n stop, minus 2r stop, plus 7n stop, plus 9r stop, and a minus 5. I noticed a couple n's, so I have 3n, positive 7n. I had some r's, so minus 2r, positive 9r, and then I also had a constant. So let's get one more color here. And a minus 5. So these we need to make sure that we write them down in alphabetical order, and constants always go at the end. So I have n's and r's. N's will come first. 3 n's plus 7 n's. 3 napkins plus 7 napkins gives you 10 napkins. Negative 2r plus 9r. So 2 dead rabbits plus 9 alive rabbits is going to give you positive 7 rabbits. And then you still have your minus 5. It may help once you've taken care of them to kind of mark them off a little bit. Sometimes I'll do that. There's one last example on the next page here. Box it up, split it up. Negative 4x term, negative 10x term. They both have x to the first, so they are like terms. So a negative 4x boyfriends and a negative 10x boyfriends is negative 14x boyfriends.